Hi class, today we will solve the problem 9.2. It's on the wind load, that is from the truss design. We will see how to calculate the wind load and we will solve 9.2. But before that, let's see the theory on how to calculate the wind load. We know that wind load F is equal to CF into AE into PD. So this AE is the effective area of the structure. A may be taken as less than the area due to the opening and shielding. So there are some special cases where we can take the A less than the actual area, but this will come into picture only when there are the openings in the structure, or this is also called permeability. This is CF, then CF is called the force coefficient from the building. So we have to refer the table B.4 to B.6 for this. And this PD is called design wind pressure. So let's go one by one. So let's see, rewrite this formula. F is equal to CPE minus CPI into A into PD. So this CF is replaced by CPE minus CPI. So CPE is the external wind pressure coefficient and CPI is the internal wind pressure coefficient. And this E is replaced by A, so we have to take the actual area or whatever the effective area. Suppose in case of the A, the area on the windward side will be more effective than the area on the leeward side. So we have to make the good choices in selecting the A, and this will go with the special cases. Then PD, it's called the design wind pressure, and this PD. Now see how to find out the PD. PD is equal to 0.6 Vz square. So Vz is the velocity of the wind at height z. Then how to calculate Vz? Vz will be equal to Vb, that is basic wind field, into all these three correction factors, that is K1, K2 and K3. K1 is the risk factor, K2 is the terrain height structure size factor, and the K3 is the topography factor. For this factor, value varies from K3 particularly varies from 1 to 1.36. So that depends upon whether the slope or theta is less than 3 degree or it is greater than 3 degree. So depending upon this condition, the K3 value will vary from 1 to 1.36. Okay, we know the now theory little bit about how to calculate wind load. Now let's try to solve the problem number 9.2. So I will read out the problem. Find the wind pressure for design of a sloping roof of span 10 meter and pitch 1/4 period. The height of the use is 5 meter above ground period. The building is situated in Madras and its permeability is normal. Full stop. Assume K1. So K1 is given equal to 1, K2 is given equal to 0.8, and K3 is given equal to 1. So this building is situated in Madras. The span is 10 meter. Span, you know that, this distance, right? This is 10 meter. And pitch is given as 1/4. Pitch is given as 1/4. So actually this is this distance, right? So if we consider this is as 4, this will be 1. So span, it is the ratio of the rise and the span. So this will help us to find out this theta or roof angle. So theta in this case will be 1/4 this total is 4, so this will be half, 1 by half, and we need to take tan inverse of this. So this will be tan inverse. So we need the roof angle, so if we take the tan inverse of this will come to 26.56 degree. So from the pitch we need to find out the angle. Problem solution. So already they have given the K1, K2 and K3 from the map. For the basic wind speed, VB for the Madras will be 50 meter per second. So from that you can calculate the VZ, right? VZ will be equal to K1, K2, K3 into VB. So if you plug in the values for K1 1, K2 0.8 and K3 is 1 and VB is 50. So if we plug in value, this will come, VZ will come to 40 meter per second. Then from this you can calculate the PD, right? So PD is equal to 0.6 VZ square. So enter the values, 0.6 into 40 square. So this will come to 960 Newton per meter square. So this PD is design wind pressure and it is 960 Newton per meter square. So we have to correct this now for the wind flowing normal to the ridge and wind flowing parallel to the ridge. So there will be two cases now. Suppose the wind is flowing parallel to the ridge and wind is flowing normal to the ridge. So let's try to solve this. So we will draw the picture. So this is the building. So this is ridge, right? Wind is flowing from this side. So this is perpendicular to the ridge, perpendicular to the this side, and this is called windward, and the windward side, and this opposite is called leeward. Hopefully you know this, right? Leeward side. So these will be the two cases, and if we see the plan, it is little bit different here, so be careful if you draw the plan. So this is the case, and then suppose this is the ridge, and suppose wind is flowing from this side, so this is windward, right? Windward, and this side will be leeward. And there are two cases, so wind is flowing parallel to the ridge, so this will be parallel to the ridge. This is the midpoint of the building, so before that, or this is called 1/4 length of the building. So area before this midpoint of the lengthwise of the building and after the midpoint from of the building lengthwise. So suppose the wind is flowing, I will read out this picture again. So you can see like this. So this is again ridge, wind is flowing this side, right? So this is windward and this is leeward. So if you refer the table, particularly we require the table B7 and B9. So this angle theta is given. If you see the picture also, this theta will be 0 in this case, and if you move this side, so then it will be 90. So be careful or be cautious, because although we are saying wind is normal, this is normal, right? Or perpendicular, because it is flowing from this side, and this will be parallel to ridge. So this is our ridge, right? So this is parallel to the ridge, and this direction will be the normal. But when wind is normal to the ridge, theta is 0, and when wind is flowing parallel to the ridge, theta is 90. So be careful while selecting the values from the table B7 and B9. I will read out one more time this picture, because this concept is little bit difficult to understand. This is your again ridge, this is ridge. So it is wind is perpendicular here, so theta is 0 here. So wind is parallel here, parallel to the ridge, so theta will become here 90. So this need to be understood. Okay, now we will come to the first case. Hope you are clear about this. So let's read all the section again. So these are the So this is the wind direction, and we have to find out what will be the coefficient of the wind. So whatever the PD we did find out, we have to multiply by the coefficient. So we have to find out the coefficient here, here, and maybe here and here. So here and here, right? These are the coefficient. This again is 5 meter. So you can refer from the book. This is 10 meter, right? So we have to find out the coefficient here, and the coefficient inside, and the wind direction is like this. So if we find out that coefficients, and if we multiply uh, the coefficients by this PD, you can get the respective values of the pressure on these uh, surfaces, roof surfaces of the this particular building. So let's try to solve this. First case, wind normal to ridge, wind normal to ridge. So theta is theta again, theta is different here. Theta is wind direction, that is 0 here, 0 degree. But if we see the theta for the angle of the roof, that theta is different, or you can, this is called roof angle, and this is 26.56 degree. So don't confuse between the two thetas. This theta is the direction of the wind, and I may call it theta 1. Theta 1 is the roof angle, that is 26.56. So when wind is normal to the ridge, so this ridge is here, right, and wind is flowing normal to ridge. So first case, on windward slope, so I will put it here again, this picture. So this is windward, right? On windward slope, on windward slope, windward slope, on windward slope, we have to find out the coefficient here. So refer the table B7, I think. Let's confirm it. So it's table number B7. So go to the table B7 and try to find out the values. So it varies between, the coefficient varies between minus 0.4 to 0 for the angles 20 and 30 respectively. So we have the value of 26.56, right? So find out by interpolation the value of the windward slope, value of the coefficient on. Okay, now we have the roof angle. So now our job is to find out the pressure coefficients, so that we can multiply these PD by this coefficient, and we get the pressure or wind pressure on the respective roofs of the building, whether it is on the windward side or the leeward side, or the wind is flowing parallel to the ridge or the normally to the ridge. So let's take the case 1. Wind is flowing, wind normal, that is perpendicular to the ridge, and we are choosing windward slope, windward, right? So if we draw again section, wind is flowing this side, so we are choosing this spot, that is wind normal to the ridge, and because ridge is like this, going like this, and we are choosing the surface of the roof which is perpendicular to the wind direction. So on this the value of the coefficient will be minus 0.4 into 6.56 divided by 10 to get the unit value. So because our value for the coefficient varies from minus 0.4 to 0 for the angles 20 and 30, right, and we need the value for 26.56. So by interpolation, so this is simple interpolation, we are getting the unit value here, and this is further we are reducing, this is the value for 20, and further we are reducing it by 6.56 units towards 0, right? So this coefficient will become minus 0.1376. Now find the coefficients on the leeward side. So second case is coefficient on leeward. So So if you see the table, then this value doesn't change. So for 20 and 30 it is same, that is minus 0.4. So for 26.56 the value will be also same, that is minus 4. Then we have to find out the internal uh, air pressure coefficient, right? Air pressure coefficient. And you remember that this is for the normal permeability, normal permeability, right? Or openings, this is also called openings. Permeability means openings in the building. So if you go to the table number B9, and if you choose for the normal permeability up to 5% of the wall area. So we know the external wind pressure coefficients, that is CPE for the windward and leeward, right? So windward is minus 0.1376 and for leeward is minus 0.4. Now just find out the internal pressure coefficient, that is CPI. So if you know both these values, then we can find out CPE minus CPI. So CPI for this kind of situation or normal permeability is plus or minus 0.2. So for this you have to go to the table B9. So when the permeability is less than or equal to normal, up to 5% of the war area, CPI is equal to plus or minus 0.2 from table B9. If you refer that table, you will see that the value is plus or minus CPI, that is internal pressure coefficient, is plus or minus 0.2. Now next is find out the effective pressure coefficient, that is combined. So combined. So this is external plus internal, or considering both. So this will be equal to, for both the slopes, that is first consider for the windward slope, this will be equal to CPE minus CPI into PD, right? So if you consider this, so CPE, external wind pressure for the windward slope, is minus 0.1376. Now consider the plus value, in this case 0.2 into 960, right? So this will come to the, if you calculate this will come to the 59.9 Newton per meter square. So this is positive value, so this is down. Positive means load will act downward, or downward, so 59.9. So on the same windward slope or windward roof, if we consider the CPI as minus 2, because the internal pressure coefficient is plus or minus 2, so if we consider now as minus 2, this will come to the minus 324.1 Newton per meter square. So this is up or lifting, so it will act, direction of the force will be upward. So these are the two values for the windward slope. Now consider for the leeward slope, right? Leeward slope. So same formula will be there, CPE minus CPI, right, into PD. But we have to consider CPI 2 times, that is plus or minus 2. So if you consider that and if you calculate that, this will come to, we know that for the leeward slope CPE is minus 4. So consider CPI as plus 2 and multiply it by 960. So this will come to minus 192 Newton per meter square. This is upward, right? And if we consider the value of the CPI is minus 2, this will become minus 4 minus 2 into 960. So this will come to the minus 576 Newton per meter square, right? This is upward because it has negative sign. So this is about the wind normal to the ridge, or case 1. So now move to the case 2. Wind parallel to ridge. Wind parallel, this sign is for parallel to ridge, right? So in this case I will draw the plan again. This is the plan of the building. So this is ridge, this is the mid point of the lengthwise midpoint of the building. So wind is flowing this way, like this way. So before the midpoint, the whatever the value of the external pressure coefficients are called 1/4 length of the building, and after this midway, whatever the pressure coefficients are called 1/2 the length of the building. So we have to calculate these values for the external pressure coefficient. So CPE, again this CPE I will just explain again. This is ridge again. So CP is on this roof as well as this roof will be the same. Here and here it will be, value will be the same. At the same time here and here the value will same. So CP for 1/4 length of the building, 1/4 length of the building, again this is table value, so it will come to the minus 0.7 on both. This is both slopes. And for 1/2 length of the building, 1/2 length of the building, this value will come to the minus 0.6, right? And again this is for both the slopes, because it is one and same for both the slopes in case of wind flowing parallel to the ridge. So we have the CP. Now we need the internal pressure coefficient. So again from the table B9, CPI will be equal to, for normal permitted, plus or minus 2. Now find out the actual values or the effective values or the combined, whatever you want to say, combined oblique effective pressure coefficients, and we know the formula. Let's do it for the so on the both the roof here, on both roof it is same, right? So we just find out for 1/4 length. So in earlier case it was windward, right, for the normal wind flow, but here in case of parallel wind flow it is 1/4 length of the building, and for 1/2 length of the building. So for 1/4 it is CPE minus CPI into PD. So take this as minus 0.7, that is 1/4. Take the value of internal pressure coefficient as plus 0.2 and multiply it by 960. So this will come to the 480 minus 480, right? Minus 480 Newton per meter square, that is upward, because direction is negative. If we take the values minus 2 for the internal coefficient, this will come to the minus 864 Newton per meter square, that is upward again. So this is for the 1/4 length of the building. Now second case, in case of the wind parallel to the ridge, is on 1/2 length of the building, 1/2 length building. So formula will be again same, CPE minus CPI into PD, right? So external pressure coefficient in this case was 0.6. Consider this internal coefficient as plus 0.2 multiplied by 960. So this will give us the value as minus 384 Newton per meter square, minus 384 Newton per meter square, that is upward, right? Then if we consider the negative value for this, so again it will be same, 0.6 minus 0.2 here into 960. So this will come to the minus 768 Newton per meter square up. So we have now different values for the different internal pressure coefficient. So just list out those values, right? So if you consider these values, so you can see that, suppose I will just let out windward slope, that is wind is normal. So with positive value of the internal coefficient, this will come to 59.9. With negative value, positive CPI, right? With the negative value, this will come to the minus 324.1 with negative. So I'm just listing out for leeward. The values are minus 192 and plus or minus 576, right? Then for the parallel wind direction, for the 1/4 slope, the values are 1/4 length of the building, the values are minus 480, and the values are, second value is minus 864, and for 1/2 length of the building, values are minus 384, and another value is minus 768. So we have to take the positive and the negative values, highest of these for the downward and the upward. So from this, design wind pressures for both slope. Design wind pressures for the structure or building. Highest of the positive value will be the 59.9. so this is highest downward, 59.9 Newton per meter square down. So this is for the downward, and the highest of the negative value, that is minus 864 Newton per meter square upward. So these are the values, design values. So this is the answer we have asked to find out these values. Thank you.